तयार करायचे, एक दॅट वॉज सॉर्ट ऑफ बायोटेक्नॉलॉजी. अशी टेक्निक 1972 पर्यंत होती, त्याला आपण कन्व्हेन्शनल बायोटेक्नॉलॉजी, ओल्ड बायोटेक्नॉलॉजी. आणि 1972 मध्ये जेव्हा जेनेटिक इंजिनिअरिंगचं टेक्निक डेव्हलप केलं, तिथून पुढे ह्या जेनेटिक इंजिनिअरिंग टेक्निकचा वापर करून जी बायोटेक्नॉलॉजी डेव्हलप झाली त्याला म्हणायचं मॉडर्न बायोटेक्नॉलॉजी. आणि ही मॉडर्न बायोटेक्नॉलॉजी ज्या इंडस्ट्रीज वापरून जे असे मेडिकल रिलेटेड असे किंवा कुठलेही प्रोडक्ट तयार केले जातात त्याला म्हणायचं RDNA प्रोडक्ट. तर आपल्याला कल्पना असेल, बीटी कॉटन प्रत्येकाला माहिती आहे. बीटी कॉटन हा जो तयार केला कॉटन आहे, हे प्रोडक्ट आहे, RDNA प्रोडक्टच आहे. अशा प्रकारचे बीटी ब्रिंजल असेल, वांगी आपल्या मार्केटमध्ये आहेत बीटी ब्रिंजल, हे जेनेटिकली मॉडिफाईड फूडच आहे. अशा प्रकारचे फूड्स असतील, मेडिसिन्स असतील, हे तयार करायला इंडस्ट्रीज आहेत. ह्या इंडस्ट्री
सर तुमचा आवाज येत नाहीये.
Am I audible?
येस सर.
अनदर इंडस्ट्री, ब्लड प्रोडक्ट्स. त्या फील्डमध्ये असल्या इंडस्ट्रीज रिलायन्स लाईफ सायन्सेस आहे, भारत सिरम आहे, बारायकल. सो मेनी इंडस्ट्रीज इन आवर कंट्री, दे आर देयर and they are producing blood related products which are required in the medical treatment. They are nowadays, you must be knowing, recently आता आपल्याला माहिती आहे पुण्यामध्ये आणि आमच्या कराडला सुद्धा आलेला आहे जो नवीन नाही येतो तसा विलियन बार सिंड्रोम ज्याला म्हणतात. हा नवीन त्याचा एपिडेमिक्स आलेला आहे पुण्यामध्ये. अशा काही 100-200 केसेस आहेत. कराडला सुद्धा आहेत, काही पुण्यामध्ये त्या केसेस दगावल्या सुद्धा आहेत. तर त्यामध्ये काय होतं तर तो ऑटोइम्युन डिसीज आहे. हे मी उदाहरण का देतो, ह्या ब्लड प्रोडक्टच्या रिलेटेड आहे. ऑटोइम्युन डिसीज आहे. ऑटोइम्युन डिसीज म्हणजे काय, तर ज्यावेळी आपल्या शरीरामध्ये एखादा बाहेरचा रोगजंतू म्हणा किंवा कुठलाही पदार्थ जातो ते आपलं शरीर लगेच ओळखतं की हा बाहेरचा आलेला पदार्थ आहे, आपल्या शरीरातला नाही. आणि त्याच्या अगेन्स्ट आपली बॉडी लगेच ऍक्टिव्हिटी करायला सुरुवात होते. पांढऱ्या पेशी आपल्या ज्या असतात त्या बटालियन म्हणून मिलिटरी म्हणून वर्क करतात आणि ते प्रयत्न त्याचा चालू होतं की आपल्या शरीरात बाहेरनं जे काय आले तो तो जंतू सुद्धा असू शकतो, व्हायरस जंतू असेल, बॅक्टेरिया असतील, कुठलाच जंतू असू शकतो किंवा काही एखादा पदार्थ जरी आला शरीरात तर त्याच्या विरुद्ध काम चालू करतं ह्याला बाहेर कसा काढायचं शरीराच्या. आणि त्यासाठी मग ते काय केलं जातं तर पहिल्यांदा तो जो पदार्थ आहे शरीरात आलेला आहे त्याला पहिल्यांदा ब्लॉक केलं जातं. त्याला इमोबिलायझेशन म्हणतात मेडिकल लँग्वेज. ब्लॉक करायचं, पहिल्यांदा बांधून ठेवायचा, तो कुठं हालचाल करू नये. त्याला बांधायचा आणि त्याची मग उचलपांगडी करायची, त्याला ठार करायचं, त्याचे तुकडे तुकडे करायचे आणि मग त्याला बाहेर काढायचं. अँटीबॉडीज त्याला म्हणतात. ते ब्लॉक करण्यासाठी काय वापरतात, दोरी त्याला बांधायसाठी कुठली वापरायची दोरी बांधायला, तर ती अँटीबॉडी नावाची दोरीनं बांधायची त्याला. आणि ते बांधलं की मग जे एकदा त्याला बांधलं की आपले जे सगळे मिलिटरी आहे, पांढऱ्या पेशी वगैरे इतर ज्याला टी लिम्फोसाइट, बी लिम्फोसाइट म्हणतात आमच्या भाषेत, ते सगळे हाताला परजून तयारच असतात. ते तुकडे तुकडे करून टाकतात, काही त्यातले खाऊन टाकतात त्याला. अशा पद्धतीने शेवटी आपल्या शरीराच्या बाहेर टाकलं जातं. हे नॉर्मल प्रोसेस आपल्या शरीरात, काही बाहेर नाही आलं तर. पण ॲबनॉर्मल प्रोसेस आताचा जो विलियन बार सिंड्रोम जे आहे त्यामध्ये ॲबनॉर्मल प्रोसेस होते. ऑटोइम्युन डिसीज मध्ये काय होतं की आपल्याच अँटीबॉडीज आपण ज्या तयार केल्या असतात त्याच आपल्या विरोधात काम करायला लागतात. म्हणजे आपल्याला मदतनीच न होता आपण तयार केलेल्या अँटीबॉडी त्या बाहेरनं आलेल्या जंतूला बांधायच्या ऐवजी आपल्याच सेलला बांधायला लागतात, आपल्याच सेलच्या विरोधात काम करायला लागतात. आणि त्याला म्हणायचं डिसीज कुठला तर ऑटोइम्युन डिसीज म्हणतात त्याला. ऑटोइम्युन डिसीज, लुपस म्हणून एक डिसीज आपल्याला माहित आहे, अतिशय डेंजरस ऑटोइम्युन डिसीज आहे. आणि हा सुद्धा आहे, आता आलेला आहे. हा काही व्हायरल डिसीज नाही. इट इज अ सिंड्रोम. सिंड्रोम म्हणजे ग्रुप ऑफ मायक्रो ऑर्गॅनिझम्स त्यामध्ये असतात, त्याला सिंड्रोम म्हणतात. मग सिंड्रोम यामध्ये पहिला मेजर ऑर्गॅन कुठला आहे, कॅम्पायलोबॅक्टर जेजुनी नावाचं बॅक्टेरियम आहे. आणि तो बॅक्टेरियम आपल्या चिकन मध्ये असतो, बर्ड्स मध्ये असतो.
एक रिक्वेस्ट येते सर, बाहेरचे दुसऱ्या राज्यातले बरेच जण आपल्या याच्यात आहेत ना, तर त्यांना थोडं हिंदी समजेल असं, म्हणजे मराठीपेक्षा.
हिंदी, हिंदी आणि इंग्लिश, नो प्रॉब्लेम.
थँक्यू सर.
Okay. I'm sorry, I was not aware of this. I'll go for in the Hindi and English. So when antibodies are produced, then in that case, these antibodies they start working against our own body. अपने खुद के बॉडी के अगेंस्ट काम करने चालू करते हैं, उसको बोलते हैं ऑटोइम्यून डिसीज. और एक अभी जो आया है गुलिनबार्ग सिंड्रोम करके, इट इज नॉट कॉज बाय सिंगल माइक्रो ऑर्गेनिज्म बट ग्रुप ऑफ ऑर्गेनिज्म दे आर इन्वॉल्व. When the major organism in that case is the just I told that Campylobacter jejuni, which is commonly found in the birds like the chicken. And if that organism in the chicken, if we eat by ill-cooked or undercooked such material, or if you handle such chickens with this organism, and if you don't wash your hands, then it is possible you may suffer by that disease. And what happens along with this disease, when other viruses, other bacteria, they also infect your body, then our body gets confused. कंफ्यूजन होता है बॉडी को कि अभी हम क्या करें. तो बॉडी क्या करती है, इस कंफ्यूजन में इस पैथोजन को मारने के बजाय अपने खुद के सेल्स पे अटैक करना चालू करते हैं, और उसको बोलते हैं ऑटोइम्यून डिसीज. तो इन दिस केस दोज एंटीबॉडीज व्हिच आर प्रोड्यूस्ड इन आवर बॉडी, जो अपने खुद के बॉडी पे अटैक करते हैं, उसको बोलते हैं ऑटो एंटीबॉडीज. खुद के बॉडी के खिलाफ काम करने वाले एंटीबॉडीज, ऑटो एंटीबॉडीज. तो अभी इसको ट्रीटमेंट क्या है, तो ब्लड प्रोडक्ट लगता है उसके लिए. ये जो अभी इंडस्ट्री में दिखा रहा हूँ ब्लड प्रोडक्ट, तो यू हैव टू डेवलप एंटीबॉडी अगेंस्ट ऑटो एंटीबॉडी. जो ऑटो एंटीबॉडी अपने बॉडी में तैयार हो गई है, उसके खिलाफ दूसरी एंटीबॉडी बनाने का, उसको बोलते हैं एंटीबॉडी, डबल एंटी. और वो ट्रीटमेंट देते हैं, उससे वो डिसीज क्योर हो जाता है. तो ऐसे ब्लड प्रोडक्ट्स, n number of blood products are required in our treatment, and that produced by those industries which are enlisted here. Then vaccines. I talked these vaccines, they are very, very important. In brief, I'll explain the principle of vaccination. Vaccine. Louis Pasteur explain the principle of vaccination. वैक्सीन का मतलब वो वैक्सीन क्या है, वैक्सीन किसी को बोलते हैं. से फॉर एग्जाम्पल, जब एनी पैथोजन से टाइफॉइड इज कॉज्ड बाय बैक्टीरियम कॉल्ड साल्मोनेला टाइफी बैक्टीरियम, वो अपने बॉडी में जब जाता है तो वो बॉडी में ग्रो होता है स्टमक में. और बॉडी में क्या होता है कि अपने बॉडी में 3 लाइन्स ऑफ डिफेंसेस है. अपना स्किन है बॉडी का, वो पैथोजन को अंदर जाने नहीं देता है. हमारा माउथ है, हमारा नोज है, ईयर्स है, हमारे ये है आईज है. हर जगह नेचर ने हमको वेपन दिया है, उससे अंदर नहीं जा सकते. हमारे जो टीयर्स है, आईज है, उसमें एंजाइम रहता है, वो माइक्रोवेव के अगेंस्ट काम करता है. माउथ में भी एंजाइम रहता है. वो स्टमक में एसिडिटी रहती है, उधर ही हम वो जंतु को मार दिया जाता है. इन आवर बॉडी नेचर हैज एंडोर्ड विद सो मेनी डिफेंसेस, बट never underestimate the power of microorganisms, because on this planet life has originated as a microorganism, single cell. And we said that if in future, if time comes that extermination of life will be there from this planet, last going will be microorganisms. Human being will go before that. This tremendous power is there in the microorganism. Now, how this is our takes place, because I have to explain this thing, vaccine. We always use this word, but majority of you must be knowing the meaning of this vaccine. But some of people, if they have no idea about the principle of vaccine, I'll just in brief I'll explain. क्या होता है वैक्सीन? जब बॉडी में से माइक्रो ऑर्गेनिज्म जाता है ब्लड में, माइक्रोब इज वेरी क्लेवर. ही क्रॉसेस फर्स्ट लाइन ऑफ डिफेंस स्किन, second line of defense stomach and all this, and enters in the blood. That is the third line in the blood is there, and in the blood antibodies are there. I told these are the battalions are there, white blood cells. इनको भी डिफीट करते हैं पैथोजेंस, और उसके बाद डिसीज हो जाता है. Now in our body one mechanism is there. Any pathogen, anything which enters in our body, it will be removed from our body say after 10 days. The body requires 8 to 10 days for preparation of defense. 10 days are required. But pathogens are very clever. Before these 10 days, these pathogens, they grow in huge number in our body. They produce toxic compounds in our body, so that body becomes diseased, and before development of your weaponry in 10 days, your body succumbs, death takes place, or you suffer by severe disease. Then you need weapons from outside, doctor and antibiotics we take from outside, because your body is not in position, because within 2-3 days that pathogen has conquered you. But if our body manages to produce these weapons in 8 to 10 days, any pathogen can be removed from our body. This is common practice. In this natural cycle is there. This is from remote past. Vaccines, what is the vaccine? As I told, when in our body pathogenic cell enters, body reads that pathogenic cell, how is her face, how is length, how is the breadth of that, like that, and produces antibody accordingly. Antibody is produced, and that antibody takes care of that pathogen, removes that pathogen out of the body. And these antibodies, they remain in our body for a long period of time. Another thing, instead of that pathogenic cell, if you cut the cell in fragments, हमने अगर उसके छोटे 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 पीसेस किए और वो पीस भी हमने अपने बॉडी में डाला, तो हमारी बॉडी क्या करती है, वो समझती है ये कि ये पैथोजेनिक फुल कंप्लीट सेल है. It will not consider this as a piece. Again, that piece, it will produce same antibody. Means if such pieces of pathogens, fragments of pathogens, if we inject in our body, then you will find that our body considers that they are pathogens, not the fragments. Antibodies are produced and they remain in our body. And after that, I told that these antibodies can remain active in your body, say for 6 months or even for some years also, or in some cases. And now really when pathogen, living pathogen enters in your body, our body knows that this pathogen already I have read it, I have seen that, and antibodies are there in body. Those antibodies immediately start acting against the pathogen, and that pathogen is not allowed to grow in our body. So these fragments which are used in our body, which we are injected fragments of pathogens, they are nothing but the vaccines. So this is a simplified explanation about the vaccines, and such vaccines are prepared from every pathogen. If typhoid disease is there, you can prepare from typhoid bacterium. If say, for example, dysentery is there, dysentery bacterium. Or if viral disease is there, from that virus, you can prepare such vaccines. So this is the technology, vaccine technology. And this vaccine technology, industries are there, and best example is Serum Institute of India, where they prepared the vaccine which was based on the DNA vaccine. Okay, so such vaccine was developed for the control of COVID, and nowadays for many such industries, they are trying, they are preparing vaccines against known pathogens, because we know thousands of pathogens are known since remote past, and now also every now and then newer and newer pathogens are emerging, and so as the pathogens emerge, then they try to prepare vaccine and they keep ready. So they are giving excellent service to the society, and these are the examples of those industries which produce the vaccines. Diagnostic, I told that diagnostic kits, they are prepared. If the disease is to be diagnosed, then in that case, those kits are available and they are prepared by the industries. Say for diagnosis of the even COVID, diagnosis of the rabies, or in case of the diagnosis of the AIDS, for every such disease, specific kit is available. They detect whether the product of that particular pathogen is present in your body or not. If it is present, they say that that person is infected by that pathogen, and disease is diagnosed. And depending upon the extent of disease, then treatment is given. These are the industries. Span Diagnostics is there, Advi is there, Roche is there, Yashraj is there, and on the basis of that, different laboratory chains are there, and we are well familiar with this. Metropolis is there, Thyrocare is there, Molecular Diagnostics are there, RLS is there in Bombay. So many chains are there where they do the service. They use service in the field of medical sciences, and in all the fields I am telling, upon n number of job opportunities are there. The people, and this is the example I was talking about, the Shanta Biotech It is in Hyderabad. The world-known medical related industry is there. In our country, this industry produced hepatitis B. There are कावीळ म्हणतो B type कावीळ त्याला म्हणतात अतिशय dangerous caused by virus and they have prepared vaccine in our country for our own Indian people in the very meager cost. They have provided this vaccine available to our country and we should thank the Shanta Biotech. There are any departments. This is in Hyderabad. You get the opportunity. Definitely, you should visit that. Now, this diagram. Many of the people, they may be knowing this serendipity discovery, it is called. Two types of research and discoveries are there. One is called serendipity and second is called targeted. Serendipity discovery means what? It is a accidental discovery. It was not decided to do research in that field and accidentally some result is obtained. That is called serendipity discovery. And second is called targeted, means it is decided in mind that yes, I want to prepare vaccine against COVID. Yes, I want to prepare vaccine against tuberculosis. That is called targeted. But when accidentally you get something where it was not desired, such discovery is called serendipity discovery. And serendip, you must be knowing why this discovery is called serendipity. Serendip was the original name of Sri Lanka. When it was discovered by the discoverer, it was accidental discovery. It was at that time name was given Serendip. And such kind of discovery thereafter was named as serendipity discovery. This example, why I have given this example, you must know that. You must know that. So this example, in this example, you will find this is a microbiological experiment which are done. And in this experiment, this is a glass plate. डबी जिसको बोलते हैं ग्लास डबी, ग्लास प्लेट, cover is there and lid below is there. It is a glass plate, petri plate it is called. And in this petri plate, the medium food for microorganism is poured. It is solidified by using solidifying agent agar. So this around this is the food inside the plate. This is the growth. These lines are the growth of bacterium. Bacterium has grown. This experiment was done by very, very famous Nobel Prize winner, great scientist, Alexander Fleming, who discovered the penicillin, epoch-making discovery in the field of medical science. What he has done? He was working with this organism. The name of organism is Staphylococcus aureus. Bacterium is there. This bacterium is involved. जो हमारे ऊन में पस होता है ना, पस, तो pus causing organism. This organism is responsible for wound pus causing and due to the wounds which are caused by this organism, in the wounds if this organism grows, it even causes death of the individual. So in the war time, in the World War, when wounded soldiers were there and big wounds were there, they were grown by this organism and pus was there and continuous deaths were caused there and no treatment was available. So that Alexander Fleming, he was working, he grown that organism in the laboratory on this medium. And then he left those so many plates he prepared. From different patients, he obtained this organism and grown. And different plates were kept there as it is. After 8 days, every 8 days, he was discarding and washing the plates for reuse. And in one plate, he found that this organism is there. And what is this? He found that something is grown. Then he tested it. He found that this is a fungus. In Marathi, we call burshi. It is a mold, burshi, fungus. And he found that the fungus has grown on the plate. And beautiful picture is there. Around this fungus, in this area, gray area, there in this area, this bacterium has not grown. So what he had done, it was a miracle for him. He took this fungus, he grown, and he found that this fungus secretes a compound, and that compound causes killing of this organism. So around this fungus growth is not there because that product is secreted, and he named that product as a penicillin antibiotic. That was the first discovery. And then that antibiotic industry started by using another species of this species discovered by Fleming was the Penicillium notatum. But another scientist, a lady worker, Nancy Roper, she discovered another penicillium species, Penicillium trisogenum, and that is used for industrial production of penicillin. And from that, the era of antibiotics started. very, very important. How this is the example of serendipity, accidental discovery in the research. This is that fungus, Penicillium, which produces penicillin. Now, in the production of antibiotics, as I told, penicillin example is there. This is a penicillin production.
पीपीटी शेअर करताय का सर तुम्ही? दिसत नाहीये सर पीपीटी.
Just a minute. All PPTs I have shared. You did not see single.
पहिलं फक्त एकदा दिसलं, तुम्ही मध्ये जरा हे गेले होते ना, तेव्हा दिसलं नाही.
एक मिनिट.
बराच वेळ झाला, 2-4 स्लाइड झाले.
PPT का दिसत नाही. बसून नाही.
करा
One
सर,
minute, just one.
स्क्रीन जे आहे ना तिथनं शेअर करू शकता.
1 minute, just you tell me which you did not see.
फक्त पहिली दिसली होती वाटतं, पहिली नाही 2-3 दिसल्या होत्या, त्याच्यानंतर नाही दिसली.
ती दिसली होती का? One minute.
हो सर.
That is visible?
Yes, sir.
One minute. Now it is visible?
Yes, sir. Yes.
You saw these slides?
सर बघितलं होतं सर.
हो, पाहिलेलं आहे. पुढे ही पण पाहिलेली आहे. ही पण पाहिलेली आहे. ही पण पाहिलेली आहे.
Is number 5.
Number 5.
Yes, sir.
This you have seen.
Yes.
Number 6.
नाही.
Number 6.
No, sir.
Okay, from this slide onwards you did not see, isn't it?
Yes, sir. No, we were in discussing, I think, number 5, slide number 5.
Slide number 5.
Yes.
Okay. Is it okay now?
Yes, sir. Yes, sir.
Okay, I explained this slide. That is the blood products where I gave the example of that recent disease which has come, Guillain-Barré, and how blood products are important. In that relation, this slide was there. That is the industries which produce blood products. In this Guillain-Barré syndrome also, we need to use antibodies. That is the blood product we need to use. And these are the industries which produce such blood products which are needed. Even in the COVID also, we needed such kind of the plasma. Then for vaccine, I explained the principle of vaccine that you heard that. Then I explained how the vaccines are produced and how they are used. And these are the industries all over India, major industries, major players which produce the vaccines. And I was talking about the diagnostics also. That is in the diagnostic, different types of kits are prepared for diagnosis of the disease. And in relation to that, different pathological laboratories are there, pathological laboratory chains are there. Common are the Metropolis is there, ThyroCare is there, molecular diagnostics, RLS, all these are there. And in big cities, district-based cities, they are spread all over India. And I was talking about that Shanta Biotech industry, and this industry is in Hyderabad. We must thank to these industrialists because they have produced hepatitis B vaccine. There is an antiviral vaccine. In Marathi we call COVID, hepatitis B, jaundice, in other words we can call viral jaundice, hepatitis B. And for that virus, they produce the vaccine, hepatitis B vaccine, in very, very cheaper cost. They made that vaccine available to our country people. So they have served our nation very well. And this, I think you did not see this slide, isn't it? Hello?
सर, ही नव्हती बघितली.
And then I'll explain just in 2 minutes. This slide, this was the experiment of Alexander Fleming. And Alexander Fleming, who discovered penicillin. Here, 2 slides are there. First slide, it is called example of serendipity discovery, accidental discovery. And second slide, where at the center hitting the arrow, we say that hitting the bull's eye, that discovery is called targeted discovery. Means keep in mind that I want to discover this work in this field, and you want to go for that kind of thing. That is called the targeted. Target is in your mind. When there is no target in your mind, accidentally you discover anything, then that is called serendipity discovery. And this is the example, serendipity. Why name this? Was I explained that name is after Sri Lanka. Serendip, this name was given, that was the previous name of Sri Lanka, and it was accidentally discovered by the discoverer. So after that, any discovery which was made in the fields, different fields, that discovery is called the serendipity discovery. Now just I'll in brief, because I have explained, but with diagram I will explain this. Figure will explain the penicillin discovery. This is the bacterium. This glass is the glass plate. In our language we call Petri plate. Where this Petri plate is there, it is in Marathi, it is dabi sarki asते, काचेची dabi. It is in that lid is there and the lower part is there. In the lower part, the medium for the growth of bacteria is added. This is the medium for growth of bacteria, and then you have to spread the bacterium on this. This bacterium was obtained from the wound, pus of the wound by the Fleming, and after 24 hours, that bacterium has grown like this. Growth of bacterium by eating the food inside the medium, it has grown. And he was studying with such different types of the plates and different types of bacteria from different wounds of the soldiers. And after 8 days, his practice was after every 8 days, he used to wash the plates. When the work is over, he used to wash the plates. And so many plates were lying around him. And while looking those plates before washing, he saw one plate where this kind of picture was there. He was surprised. What is this picture? He found that this picture indicates that this is something, another organism grown other than this, and around this organism in this area there is no growth of this organism. So he thought that this organism must be producing something, and that is not allowing, or it is, in other words, it is killing this organism in this area. He studied this particular white patch, and he found that that white patch was the fungus, Bursi we call fungus. And he named it as a penicillium. It was a penicillium, and he found that it produces secretes a product that diffuses in this medium, and due to that, in this area, that particular product is there, and due to that product, there is no growth of this organism in that particular area. So he found that ultimately he confirmed that the product which is produced by this organism, penicillium, he named it as penicillin. And this penicillin kills this bacterium. This discovery was made by this person. And after this discovery, then this organism was identified, it was grown to produce industrial production of penicillin. But the organism, another organism of this type, species was isolated by the Nancy Roper, a lady worker, and that species is the Penicillium chrysogenum. And using that Penicillium chrysogenum, industrial production of penicillin started in 1942-43. And after that, and now that since then it is available in market. It was a epoch-making discovery because that resulted in controlling of many organisms and many diseases of this kind of organism. And still this penicillin and its derivatives, they are in market. This is the penicillin, structure of penicillin. Broom-like, jhadu-like structure is that is called broom-like structure. And these are the organisms which produce different kinds of penicillins. See, this principle which we call, in Marathi we call it as katyana kata kadne. Here, one bacterium causes disease and another bacterium produces antibiotic to kill that bacterium. So in this way, after discovery of penicillin, then scientists, they screened out different types of sources, that different types of soils, water bodies, air, and they isolated different organisms and studied for what any kind of antibiotic it produces or not. And they found that many antibiotics, hundreds of antibiotics are known. We know these are the very common penicillin, streptomycin, tetracycline, erythromycin, chloramphenicol, gentamicin, kanamycin, like that, and which organism produces, it is there. Means tomorrow, if any person gets single organism like this and get the production of new antibiotic, in a day he can be multi-millionaire. Only thing is that he has to develop the tech methodology from production of that particular antibiotic from that particular in the industry and go for industrial production. This is another antibiotic battery there. Special antibiotics these are called. Their applications are special. This first antibiotic, downurubicin, produced by this organic bacterium. This downurubicin is anti-cancer antibiotic. More than 5 crores per kg. Cost is 5 crores per kg. This lovastatin antibiotic. This is used to reduce cholesterol from the body. Again, very costly. But they are produced by microorganisms. Microbiologists and biotechnologists must go for getting such kinds of microorganisms. Vitamins. See, vitamin B12. Always doctors, they say that you have deficiency of vitamin B12 or vitamin D and other vitamin deficiencies there. Then we take the vitamin tablets. Doctors, they suggest prescribe the vitamin tablets. They are available. They are produced by these microorganisms. Before discovery of production of vitamin from microorganisms, you know, vitamins कैसे बनाते थे? They were preparing vitamins from the sewage sludge of the city, from any big city. When the sewage is accumulated somewhere, the sludge accumulates at the bottom. They were collecting the sludge, and from the sludge biomass, they were collecting the B12, the B12 like and other B complex vitamins, and from that they were preparing tonics and the tablets also. We were eating those at that time, but nowadays that practice is stopped and they are produced by microorganisms. These are the vaccines just I explained. These vaccines, hepatitis B, cholera, MMR, mumps, measles, rubella vaccine, typhoid, BCG. There is a tuberculosis. Bacillus calmette-guerin name is there. DPT is diphtheria, pertussis, that is a whooping cough. And this is a tetanus. So all these vaccines, they are produced in our country nowadays. Many industries are there, and n number of job opportunities. They are there not only for the medical related people, but to any other branch also they can enter with some skills development. Recombinant DNA products, they are there. So many products they are available. I explained the recombinant DNA technology, and here you will find that these are the products. Only one product I will explain to introduce you to this science: insulin production. I told that जो गुणसूत्र जिसको बोलते हैं जीन, इंसुलिन प्रोडक्शन करने के लिए जीन जो रहता है वो अपने क्रोमोसोम में जो बीटा सेल्स ऑफ आइलेट्स ऑफ लैंगरहैंस इसको बोलते हैं, पैंक्रियाज में रहते हैं, स्वादुपिंड में जो गुणसूत्र रहता है उससे वो इंसुलिन तैयार होता है. जब ये इंसुलिन अच्छी तरह से तैयार नहीं होता, प्रोड्यूस नहीं होता और इनफ क्वांटिटी में तैयार नहीं होता तो आपको डायबिटीज हो जाता है. Now, before development of this insulin, human insulin is available in market. Recombinant DNA insulin, which is produced by using microorganism. Insulin is human being animal product, but now it is produced by using microorganisms. That is called humulin. That is available in market. But before that, what they were doing? When people they were suffering by diabetes, then they were taking insulin from animals. Cattle, they were slaughtering the cattle, and after slaughtering the cattle from their islets of Langerhans, from pancreas, Swadupin, they were extracting the insulin and that was used. But that insulin was not enough, because one thing is that never-ending demand for the diabetes. India is the hub of the diabetes. Every 3 person is suffering by diabetes. Then how much amount of insulin you will get from animals? Worldwide, if you look at, how many animals you will sacrifice? We use what? Sacrifice. Literally, we slaughter the animals. Cruel human being we are. We slaughter the animals and we get the insulin. That was not enough. One thing. Second thing, that there was animal insulin. 100% working was not, functioning was not there in the human body. And third thing, many people they suffered by allergic reactions with that. So it was necessary to produce insulin in huge quantities by using any good technique, and the technique was recombinant DNA technology. That gene was put into Escherichia coli cell, bacterium, as well as Saccharomyces cerevisiae yeast. And if you grow that yeast in the quantities, in same quantities, you will get the insulin. Means nowadays, tons of the insulin is available with the modest cost. And that is the beauty of this technique, recombinant DNA technology. And such products are, n number of products are available. I have given example, BT cotton is there, BT brinjal is there, BT tobacco is there, BT vaccines, RDNA vaccines are also available. For example, fruit vaccines. We know that many people, they are having they are afraid of what is called that syndrome, white collar syndrome. They are afraid of doctors. They are afraid of injections. So many commonly we take vaccine by injection. But by this technique, now fruits are developed. Apple fruit vaccine, banana vaccine. You eat a vaccine, but banana, you are vaccinated. You eat the vaccine, that is the apple, you are vaccinated. Therefore, vaccine fruits are prepared, and all such are examples of RDNA product, and they are available in market. In India also, so many of them they are available. Then major the players in this particular RDNA area. These are the examples of industries where they are around us. Say Serum Institute is there, Shreya Biotech in Pune is there, Hyderabad, there are so many, Aurangabad, you are there, Okar is there in Aurangabad. So many such industries, there are good players for the production of RDNA production servicing our nation. One important thing which I was explaining you, that is the preclinical research I explained you. When you want to produce any new drug, what is the process? The new drug process is that very simple process. I'll tell you. New drug you want to prepare. Say COVID vaccine you want to prepare. How to prepare it? Technique is very simple. Say for example, COVID virus, when it enters in our body, it enters in our lungs and it attaches to specific lung cell. वो अपने फेफड़े के सेल को अटैच करता है, जाके अटैच होता है. वो अटैच करने का उसका जो पार्ट है, सपोज फॉर एग्जाम्पल इफ यू से 2 hands are there of that particular virus, COVID virus. With those 2 hands, it goes and catches to the cell in the lungs. Now, how to prepare the product to control this particular virus? If you block the hands of that virus, that part of that virus which is going and binding to the cell, if you block it, so for the blocking purpose, you have to produce that product, a product which will block the hands of that COVID virus. So what you have to do now, once you have detected, you have identified the target. Your target is blocking the hand surface of that COVID virus. So this is the first step. Identify disease and which is the part target which is to be blocked. Then you have to synthesize. You will synthesize many products. Yes, you have synthesized 50 products and you are testing whether it is binding to that hands of the virus or not. You are testing, and when you found that all the 50 they are binding, so they are called the hits. They are binding to the hand. Now that is not enough. After hits, you have to test. You have to test it. Means you will develop the 50, you will produce in large quantities, development, and then you will go for testing in the animals. First animal, pre-clinical, and then clinical, that is in case of human being. Phase 1, phase 2, phase 3, phase 4 trials in the human being. Now first tested in the animal. That your product which you have produced, first inject the virus or first inject your product in the body of that animal, in the lungs, and after that inject the virus and see that virus its hands are blocked. Now what will happen? If hands are blocked of that virus, it will not be able to bind to the lung cell. If it will not bind to lung cell, it will not grow. It will be given out of the body. Disease will not be caused. Means when you have prepared such 50 products, you have to find out which is the best. Because what will happen? Sometimes it happens that a product is binding to the hands of virus, but at the same time it is binding to the lung cell also. So it is causing side effects. So out of 50, if you found that all the 50 are failed, 50 are binding to the hands, but they are causing side effects in the lungs. So your whole attempt is failed. Clinical trial attempt is failed. And this clinical trial requires the period of more than 7 to 8 years, maybe 10 years or 15 years. And the industry has to spend thousands and lakhs of crores of rupees on these trials. If 50 and such hundreds of the trials you have taken and all are failed, and if you say, for example, 50,000 crore rupees are wasted on this, what will happen to that industry? So such kind of work is done by only multinational industries who have buffering capacity, that if this kind of failure in the experiment is there, still they can work ahead. So in our country, we don't have a single industry which can go for this kind of the clinical trials, because that buffering capacity we don't have. The industry which fails in this way and they have buffering capacity, what they will do? They will produce again additional new 50 molecules. And out of those 50 molecules, if one molecule works, that no side effects are there, it is binding to the hands of that virus, then what will happen? They will be at the driver's seat. Then they will produce that particular product in large quantities, and that can be used for control of that viral disease. And this is the basic principles in new drug discovery. Produce a product, test it, and out of that, which the best you get in the animal trials, first in the animals, there is the rats and monkeys and dogs and cats, and then trials are taken on the human being. Phase 1, phase 2, phase 3, phase 4 trials on the human being. And it is not easy to go for trials on the human being. Who will allow to inject such kinds of the viruses and dangerous products produced in your own body? But still these trials are going on. I'll further explain that how these people in those industries they manage these trials. These are the trials, and these are the industries where again these clinical trials are performed. These are the list of industries where clinical trials are performed. I am proudful my college, that is the Krishna Institute of Medical Science and deemed to be university. Here also clinical trials are performed. And in those clinical trials, when I told that you can prepare the those products, new drugs, either from natural sources like plants, herbal plants, or you can chemically synthesize. And this is the example of target. As I told that the hand of that virus, COVID virus, these two hands. So that is the target. So such targets are first selected, and then target blocking antibody or any product is produced, and that product is used to control, to prevent this particular pathogen to grow in our body and control the disease. Now I am coming to this point. I told that clinical trials are very difficult, where you will get the human body for the trials and experiment. See what is written here. India, a nation of guinea pigs. We people were called guinea pigs. Experiments are done on the animals, and one of the common animals is the guinea pig. So in human population is called guinea pigs. Why? Why Indian population is selected to do trials for the drugs? Because when you do trials for the drug, many people they die in the trial, because that drug which is prepared, newly developed drug, it is not known whether it is safe or unsafe. When it is unsafe, in that case, many people they die. Means in that way, Indian population is exploited. And why these multinational companies, they have selected Indian population for such kinds of trials? Reasons are like this. We have huge human population and patient population. In हमारे country, in हमारे देश में, you will find that variety of diseases are found. Diseases of Western world and diseases of tropical. See, the diabetes is there, HIV is there, epilepsy is there, rheumatoid arthritis is there, cancer is there, heart problems are there, Alzheimer, the blood pressure is hypertensive, so many, schizophrenia, every kind of disease, you take the name, that patient is there in our country. So here, one thing, huge population, 145 crores. Every type of disease which is found in the world, it is found in India. And that patient population is huge. Large number of patients are available, so India is selected number 1. Second, why India is selected? Standard of care. Our medical care, medical infrastructure is huge and big and standard. In our country, more than 6 lakhs English-speaking doctors are there. Industries, they select the country for such trials where English is spoken. And we know in our country, English is spoken. Our majority of the doctors, they talk English. Why these industries, they don't select China or Russia or other countries? Because in those countries, English is not spoken. So for those industries, it is easy to communicate with our Indian doctors and medical people. So many people, they talk English. This is second point. Third point is that here, all the treatment norms, if you look at worldwide standard treatment norms which are there, treatment standard which is there, that is followed in our country. If you look at the manpower in our country with respect to medical science, 20,000 medical graduates per year they are produced in more than 200 recognized medical colleges. And every year, we know that college number is increasing and that student population is increasing. More than 40,000 hospitals are there, very good hospitals. They are available. And in those hospitals, more than 8 lakhs hospital beds are available. Hospitals in the urban and semi-urban centers have modern infrastructure and all auxiliary support in that. Means medical facility is excellent, patient population is huge, doctors are good, they talk English, and that is one of the reasons why they select our country for this trust. And in fact, another thing is that slum area is there, poor people are there, and the poverty line is there. So these multinational industries, they use they go for malpractices. They show the money to the people, and to the poor people in slum areas, they give the lakhs of rupees and ask them, give your body for the experiments. In the experiments, if you die, will give huge amount of money to your families. And in that way, these malpractices are there. Actually, consent is necessary. The written consent is necessary that nothing will happen from this trial. But these people, multinational companies, they are with fact, are a huge exorbitant money is there and money power is there. They are using our country. Research in the field of transgenic plants and animals. Recombinant DNA technology in the plants and animals. Our plants, they supply to us food, protein, fiber, medicines, shelter. Like animals also, cattle, sheep, goats, pigs, they supply us to milk, other food, protein, fiber, leather, milk. But problem is that the human population is increasing, never-ending demands are there, and these sources, natural sources, they are not fulfilling these things. So it is necessary to genetically modify the plants, genetically modify the animals, which are producing higher, say for example, higher crop production, higher yield is there, good quality yield is there, in less amount of water, in less amount of nutrients. Means in other words, in Marathi we call Choti Shingasli guy, small horns, less eating, not fighting, not aggressive, and giving large amount of milk. Such kinds of plants are being produced, animals are being produced, and the technique is going to, so that in future, because that will be future problem for our country as well. But for that future, our industries, they are going for these kinds of products. There is a growing human population, demand supply we cannot meet, and this is a futuristic problem, and so it is necessary to go for transgenic plants and animals, and that is called science of transgenosis. Everybody, simple, common man also can do such experiments in his, say for example, in case of the agriculture field, plant tissue culture. You can develop newer and newer varieties of the different plants with desired qualities, high yielding, less, even growing in the salty condition. The adverse condition also growing, adverse atmospheric condition they are growing, and a huge amount of product is produced. Like that, plants and animals, they are produced. That science is called the science of transgenosis. And in that field also, this technique is not at all difficult. A common man from any field, if he learns by simple 3 to 6 months course, he can develop this technique in his own fields. And these are our, we should salute these people who have developed this plant and animal tissue culture and genetic engineering. These are the scientists. In the plant tissue culture, you will find that all these products they are now available, and in every industry, every person has got the chance. Nutraceuticals, edible vaccine, just I told, apple vaccine, banana vaccine, pharmaceutical, and this is a technique. Forget that technique. And here, using this in plant tissue culture, you can get all these things. And now, even at the rural area, also many farmers they are going for this kind of the technique. by putting any person who is skilled in that field. So this is the example of transgenic plants produced by genetic engineering, plant tissue culture. This is G.R.Pathade means errand. See, in the test tube plant is grown. In this plants are grown and then they are uprooted and then you can put in the soil. You can grow that plant. When you are growing in the test tube, experiments are done in the test tube. In those plants, you can introduce desired qualities, and then that plant will have with the desired qualities. You can put in the soil, and such lakhs of the plants you can grow for any kind of the crop. See, like this. You can prepare artificial seeds of the plants. We know seeds are there, natural seeds. They are susceptible to the that is what we call the destruction by the insects and all that. Spoilage is there, but you can prepare seeds, natural artificial seeds of the plant, and they are not infected by the insects and they are very safe. So in this first plant, if you take small piece of plant, very small, and put on a medium, in this way first plant grows, and then you have to apply with the different hormones, and then you can develop a plant, which I have shown in this test tube. Then this plant grows like this after hormone treatment. And this is the best example where you can develop these are some of the plants which we use aromatic plants and medicinal plants, and they should be protected. And nowadays this technique is used for protection. Another is the probiotics. You must be knowing probiotics. Everybody has heard the word probiotic. Curd is probiotic. Probiotic means we eat the microorganisms in the form of tablets or syrups so that our stomach health is maintained. And that product is known as probiotic. One simple example, this name of the scientist is E.V. Mechnikov, the first Nobel Prize winner. He discovered the phagocytosis and he got the Nobel Prize. Now, same person, he was working in the Bulgaria and he found that Bulgarian people, farmers were there. They usually they were having a very long lifespan, 125 years, 130 years, 140 years, like that. And he was surprised. Why such a long lifespan? Then when he studied their life, their whole life cycle, he found that they eat large quantity of fermented milk products in their diet. Means 1 kg, almost 1 kg per person per day. And he proposed a theory of longevity of life. You can increase your lifespan, eat more and more amount of fermented dairy product. So for example, butter, or for example, curd. Eat almost 1 kg per day, your lifespan will be increased. And this theory gave boost to the development of this science. Because if you want to increase your lifespan, just you eat the curd. Then it was found that this theory was like that, not like that. This theory was, his proposal was wrong. People's lifespan was not increasing, but they were reaching to their normal lifespan. Normal lifespan of human being is around 140 years maximum, 150 years, say, for example. Then they were reaching to their normal lifespan, which is up to maximum. In normal cases, what happens? We people eat large amount of proteins, and in our stomach, anaerobic proteolysis takes place by the microorganisms. Very, very toxic compounds are produced, and every day, every now and then, these toxic compounds are absorbed in our body, and that results in slow poisoning, and that reduces your lifespan. This is our common. Hence, our lifespan is less than 100 years. But it was further proved that when you eat fermented dairy products, in that one bacterium is there called lactobacillus. And these bacteria, they inhibit, when you eat large amount of this bacteria with the curd or other thing, then they kill, you can say, those bacteria which cause anaerobic proteolysis in your body, and toxic compounds are not produced. As toxic compounds are not produced, as no slow poisoning is there, you reach to your normal lifespan. So this was the theory proposed behind this, and this theory this particular phenomenon is still applicable. And hence, if you remember, in our country, this is not new. We eat curd since long. In Ayurveda also it is mentioned, you take the curd if you have the digestive disturbances. Then if you take the curd without changing the microorganism from that is called the culture. Without changing the inoculum or culture, if you for at least 1 month, same curd, if you eat for 1 month daily, then you'll find that all your digestive disturbances will go away. And this is the significance of the probiotics. Anybody can work on this. You can take the curd, you can take other fermented milk products, you can prepare, or you can prepare lassi, you can ferment even different type of the millets with the curd and prepare a newer products and bring in the market. So any common man also can enter in this field, and you can get the success of that. You can become entrepreneur. This is say no to antibiotics and say yes probiotic. Don't take antibiotics. Nanoparticles. Nanoparticle means what? You have to prepare a particle of such a small size. Small means up to what extent? If you know 1 meter, if you cut that 1 meter into small pieces, small pieces, till the size of 1 upon 100 crores, 10⁻⁹. 1 nanoparticle is size, its size has come to meter is 1 upon 10⁹ meters. Means 100 crore part of the meter is the nanometers. If you prepare such small size particles, they become very novel particles. Again, this science is not new to us. In Ayurveda, you must be knowing, they prepare the powders by what we call the culling, in Marathi we call, by crushing. They are produced in the form of nanoparticles, and then from those particles they prepare different tablets which are called vatis, and they prepare other Ayurvedic preparations. And this science is now developed, and this is called the father. In fact, Indian must be the father to this. Nanoparticles, this size I told, you can prepare nanoparticles up to 100 nanometers. They are used. Say this is in two bottles I have told. One bottle with yellow color, one bottle with reddish color. Yellow color is the one solution. It is a silver solution, silver nitrate. In that, if you add microorganism, within no time, color change to yellow, or this is dirty yellow to red color. When it turns to red color means nanoparticles are. Same is with this yellow color is the gold solution. That is a gold aurium chloride that is called. And if you add microorganisms, immediately turn to red, nanoparticles are produced. And these nanoparticles, now they are studied extensively. They have got tremendous medical application, in every field application is there. When this nanoparticle solution is observed under the microscope, that is compound microscope, when you magnify, say 20,000, 30,000, 40,000 times, then or lack of the time, these particles, they look like this, like our in Marathi we call shabudana, isn't it? Like that small particles they are commonly of the round size, but they can be of variable sizes. And these nanoparticles, they have got different applications. This is a medical application. I have given the example of Fleming's experiment, serendipity experiment. You will find that here, this is a Petri plate. This white color is the growth of bacterium, and at the center, the nanoparticle solution is kept. The solution diffuses nanoparticles in this area, and you will find in that area where nanoparticles are diffused in the medium, no growth is there. Organism has not grown, it is killed. And depending upon the concentration of more particles, in more area, there is no growth. So it is shown that this particular nanoparticle, a particular metal is, or a particular element is inhibiting this or killing these microorganisms. And in this way, in addition to antibiotics, we can use these nanoparticles. If any antibiotic is found useless when organism is resistant to that, then the antibiotic can be attached with the nanoparticle and then it can be tried. So this is a nanotechnology, and this nanotechnology is useful in the all the fields. Medical field is there, then industrial field is there, environmental science is there, agriculture is everywhere it is used. And simple technique, any common man can develop this technique. Vaccine, I will not go into details of vaccines, just I explained that. This is the example how vaccines are produced. This is a practical example. They are produced even in the egg, egg yolk. Most of you are science people. If you take the egg with the embryo, that inside this egg yolk or this in embryo, you can grow the particular organism, bacterium or virus, and then that organism is taken outside, washed, and that organism is killed, and killed organism can be used as a vaccine. So in this way, we can prepare the vaccines, or you can grow these vaccines on the tissue culture of the animal, and those animals on the animal cells after growing, you can collect those cells and you can prepare the vaccine. Or you can synthesize the vaccine material, chemically you can synthesize. Can you see something? This is a stem cell. stem cells are grown on the medium, and they are the stem cells. This particular stem cell is grown on the medium, and the stem cell material is taken from heart. Can you see the movement? Yes, can you see the movement? On the plate, glass plate, this from single cell, when this layer is produced, in the where here you will find this arrow is there, and movement like heart is there. So these are the cells, stem cells, and stem cells are those cells that are called the cells. From single cell you can produce any organ. In brief, I'll explain this for this common man, that when embryo is formed, means from father sperm and from mother egg is there. When there is this sperm enters into the egg, that results to formation of fertilized egg. Embryo is formed, single cell embryo is formed, and then that embryo in the mother's womb starts growing. From one cell, again 2 cells are produced. They are identical to each other. 2 to 4 cells, they are identical to each other. All these are stem cells. Up to extent, few months, few weeks, this process starts and it forms one bulk. Bulk of the cells, stem cells are there, and all these are the cells which are totipotent or pluripotent cells are there. And then after that boundary, then message comes to the cells that now stop growing like that, form the organs. अपने जिसको अवयव बोलते हैं वो डेवलपमेंट स्टार्ट होता है. Formation of eye, formation of hand, formation of heart, liver, like that in the body, and then whole body of that fetus is formed. Okay, that is called organogenesis or differentiation process. So till that differentiation, the cells which are there, those stem cells are there. Many such stem cells are there in the umbilical cord of the mother, the cord between the mother and the fetus. So that cord is taken, the blood is collected from that. In that you get large number of these stem cells. If you preserve those stem cells in the, that is called the blood bank, that is bank, stem cell bank. So that can be preserved from that those cells. If the person whose those stem cells are there, when it grows further in the future, if that person requires those stem cells can be used. So for example, if the person suffered by the diabetes, means his cells of the islets of Langerhans, that is the pancreas, they are not working. Then these stem cells which are in the bank, you can take those stem cells, you can inject in the pancreas of that person who is suffering by diabetes. It is expected that again new pancreas cells will be developed and person will be free from diabetes. So they say that in such many diseases we can use this stem cell therapy is there, but still it is a premature science. People, they are working. I told that you have to go for clinical trials. 10, 15, 20 years are required, and this is stem cell. So from single stem cell you can prepare different products. I have shown here single precursor. This is small.
Excuse me, sir.
Huh?
After this slide, shall we have a break for a while?
Yes. Just I'll explain this slide in 1 minute. We'll have break.
Okay, sir. Thank you.
Yeah, yes, sir. Thank you. So this is a one small cake. This is origin. From this cake, you can prepare other types of the cake. This is one type of cake. This is another type of cake. This is another. Like that, from single type of the stem cell, after differentiation, different types of body organ says this is a eye, this is a heart, this is a lung, this is a head, like that, bones, and like that. Ultimately, all organs are produced. So this is the process of differentiation and organogenesis in the body of every fetus formation. And this is the significance of stem cell. And these stem cells are in that field also. The applications are, so these diseases are cured, expected to be cured by this stem cell technology. So this completes. I'll stop here. This completes the fields where avenues are there, where opportunities are there for the job or any kind of the work you want to do. And after that, last part which I will cover, where how exactly the research is done. So we'll wait for how many? 10 minutes, okay?
Yes, sir.
Yes, sir.
We'll wait for 10 minutes. Exactly at 4:45. We'll start at 4:45. लाईट झालं. आणि फोटो कॅमेरा
म्यूट करा सर म्यूट करा इथं ते 3 टीम बघत राहत त्यात काय बघा निळं म्हणजे तुम्हाला मग हे करायचंय हे मोठं करायचंय का ना
गॅप दिले ना. गॅप दिला झालं त्याला.
हा
दिलं होतं ना? लक्षातच नाही. अर्धा दिवस. हम्म. काय?
म्हणजे फर्स्ट इयरचे मुलं आता दोन्ही पाठ दोन्ही
चालेल मग. ठीक आहे बसा मग 2 मिनिटात जायचं मला ते ठीक आहे. ठीक आहे. Hello, am I audible?
Yes, sir. Yes.
All delegates they have gathered. All delegates they have come.
Yes, sir.
Shall I start?
Yes, sir.
Yes.
Please start.
Okay.
Yes, sir. Okay.
So, in this particular lecture, I discussed the first in just a small time. I discussed about the job which we do, all we do, and the significance of that. And after that, what are the avenues available? We discussed, especially I know that being a medical person, so I tried from that side only. But still, in all this field, everybody has got opportunity. And after that, if you talk about as a way of the academic people, uh, we need to do the research and research avenues which are available there also I told. Now how to do the research, that is very, very important. And in the research, we call them as we all who are doing research, especially we all are the student lifelong teacher is a lifelong student, and all the students including us we are the pillars of nation and having the patriotic spirit. To whom we call scientist. Scientist is that person. I told at the beginning, everybody is scientist. The man who looks at nature with open eyes, unbiased, non-prejudiced, looks at nature with open eyes, is called scientist. जो नेचर को अपने ओपन आईज से देखता है, he is a scientist. Our eyes are open, but we are slept. Our eyes are open, but we are slept because we never observe nature as a third person. Our mind is prejudiced, and hence the scientist which is there in our mind is slept. So we have to make our scientist to open his eyes and go for the research. Now, so if you look at some great scientists and their contributions, how they develop their research. Newton, it is said that Newton discovered gravitational force. Gurutvakarshan, gravitational force is discovered by the Newton. Now, if you go to the literature, Indian literature, you will find that long back before Newton, even more than 1500 years before Newton, in our Sanskrit literature, there are slokas where they have talked about what Newton said. All the three laws which are there. Regarding those laws, Sanskrit shlokas are there. But unfortunately, at that time, India was not powerful. India was disintegrated into different types, small states. But now India is very strong. And we should literally really uncover the mystery of that part. And we should see really it was our own contribution. But of course, presently, that credit goes to the Newton, where he found that the fruit is going down, falling down, and why it is falling down. He discovered that there must be some force which is attracting the fruit, and that is the discovery of the gravitational force. Means here this is a serendipity discovery. Newton, it was not decided by Newton that now I will sit behind the tree, below the tree, and now I have discovered the gravitational force. It was not the case. It is accidental discovery. Similarly, penicillin discovery by Fleming. Another scientist, Darwin, who discovered evolution. Man is evolved from monkeys, like that. Mendel, he's called father of genetics. He was not geneticist. Still, he discovered he made contribution to the genetics. In fact, you will find that if you see the literature, many scientists who are non-biologists and made outstanding contribution in the biology. Louis Pasteur was not biologist, he was an organic chemist. He made 14 outstanding contributions in biotechnology and microbiology. See, this I mentioned 14 contributions. So he's called honorary father of microbiology and biotechnology. Robert Koch, he was German. He discovered first time that the microorganisms cause disease. In case of cholera and tuberculosis, he discovered the cholera organism and that is microbial tuberculosis and Vibrio cholerae were discovered by this person. That is called germ theory of diseases. So Joseph Lister, he discovered antiseptic surgery. Means at that time, when they were doing the surgery operations, the problem was the wound infection. Surgery wounds were getting infected by the organism bacteria, and the patients were dying. At that time, this was the first man. He used antiseptic surgery where he used carboxylic acid first time. Carboxylic acid, which is called phenol, he used, and he showed that we can control the wound infections. This is very important discovery. Discovery of insulin, Banting discovered insulin, and then people realized exactly what is diabetes. Godfrey and Hounsfield and Gravel discovered CT scan. We know what is the CT scan nowadays. This is a common word. Brain, tumor, and other those related studies we perform. That is called the scanning technique is there. Very advanced scanning technique, the medical CT scan. Selman Waxman, he discovered the tuberculosis treatment. That is, he discovered streptomycin antibiotic. He found that in the soil, bacterium tuberculosis, that is this organism, is killed in soil, and he saw that he found that in the soil, when bacterium is there, it produces antibiotic, and that antibiotic kills the tuberculosis bacillus, and that was the discovery of streptomycin. Marshall and Warren, they discovered this organism, Helicobacter pylori. Most of you must not be knowing this organism, but you must know this because This organism is present in the stomach of 85% people all over the world. 85%. Helicobacter pylori, it causes peptic ulcers. Many times we feel that I am suffering by acidity. In fact, it is not acidity. It is the ulcer caused by this organism. It is easily controllable, but recurrent infections are always possible because this organism commonly spreads from the food and the water. And it was discovered by this other person. Paulberg, Cohen, and Boyer, these three scientists, they are known as fathers of genetic engineering. And just I explained what is genetic engineering and its application to do vaccines or the cloning and gene mapping. All these examples are there. These contributions are made by these scientists. So these are modern scientists, we can say. Now, other diseases like medical instruments, which are other discoveries, stethoscope. Doctors always use stethoscope to measure the heartbeats and the regularity of the heartbeats. You know that before discovery of stethoscope, doctors they were merely using small cylinder, and through that cylinder they were measuring the heartbeats and their regularity. MRI, their PCR, all these newer and newer instruments are there in the available market, and many instruments are prepared by not a complete technical people. Some non-technical people also they help in preparation of these. Means your observation, any common man can observe, and through their observation also newer and newer discoveries are made. Other work like microorganism discovery, biotechnology, microbiology, pharmaceutical microbiology, pharmaceutical science, medicine, all these are the sciences where newer and newer discoveries are constantly being made. This is one very important discovery, beta endorphin, that is called natural painkiller. It is produced by the brain. When you have any pain in the body, you need to wait for 3 to 4 hours. In 3 to 4 hours, brain itself produces painkiller, and your brain, that is whatever pain is there, it will stop. But unfortunately, we don't have time. Nobody waits for 3 to 4 hours, and immediately we take painkiller. But it is the rule of nature. When from outside, if you take anything, that particular thing, the painkiller will not be produced by body. Body will not go for any wastage. If ready-made things are obtained from outside, why body will waste the energy? Because Mother Nature is best economist. No wastage in the biological system is there. So if beta endorphin, instead of that, if you take painkiller like crocin and all that, then body will not produce. After a certain period of time, body will stop production of beta endorphin. India's contribution, if you look at Indian saints and sages, really they were the scientists. Charak is there, Sushruta is there, Ayurveda, the literature is there, Aryabhatta is the scientist, Varamiri is there, Panini is there, Sukhatme Madhuri, statistician. Our discovery by Bharadwaja, that is the aeroplane, zero, pi, Pythagoras theorem, different Vedas, quantum physics. About that, Dhaneshwara, in Dhaneshwara you find some aspect of the quantum physics are there. Senses say there is a supernatural power. They were having sixth sense. If you have that idea, you will know sixth sense. Astrology, or if you read the literature of Chandeva, you will find that miraculous things that they have made. Astrology and calendar, Panchang, that is calendar that Indians are known for that. Different the yogas, Kautilya Arthashastra is there. Then our Lord Shiva Chhatrapati, Shivaji Maharaj, the Yuddha Kala, that is we call the guerrilla war, that technique. This our people, their contributions are huge, right from remote past. Unfortunately, they are overlooked by the modern world, and we people also, our people also, they are responsible for that. We always say, unless and until there is time from the Western world, we will not accept our own Indian traditional knowledge. That is unfortunate part. But our people, they were differently, they were having tremendous potential for in all the fields in our life. Now, research science, everybody has scientist mind, work in life, simple work, for example, cooking. Our mother cooks in the home. That is also the science. That is also research. Because always we say every mother's hand taste is different. Although same spices, same materials used, same raw materials there. If you ask 3/4 our mothers, different mothers to prepare, you'll find that taste will be different. There is research in that. There is research in that. Then simple cleaning technique is also there. Definitely science is behind that, and everybody has that technique. complicated research, if you look at, that is the molecular biology procedures, genetic engineering and all that. For work, two things are needed. Science involved in your work and methodology. If you know the science involved in your work and if you know the methodology, nothing like that, you can go for the research. No work can become perfect without good scientific base and sound methodology. And for that purpose, we as a teachers, we as a scientists, we should have sound methodology with us with the thorough scientific knowledge. Research, this is scientific word is French, and that is a careful investigation or search for the knowledge. Definition, scientific definition is the activity designed to test given hypothesis, permit conclusions to be drawn and contribute to the increase in the knowledge of science. Means in the research, you have to see the problem, hypothesis, you see problem and work on that, draw conclusion, and that becomes your research. If your science base is firm, you can go to the firm research. In every specialty, say medical science, engineering science, physics, chemistry, biology, math, psychology, philosophy, management, economics, food science, space, agri, environment, then other sciences like arts, commerce, music, fine arts, everywhere on all these sciences you will find that one can do the research. So for example, in even arts also one can do the research. Say music is there. If the ragas are there, music, the classical music is there. So for example, I will quote here one example of one song which is sung in 4 different ragas. 4 stanzas, 4 ragas are there. That is the song of Asha Bhosle. You must be doing Enara Na Tha. 4 different stanzas are there, and each stanza is sung in different raga. If you take all this song, same song, and if you bind the every stanza in other than these ragas which are used, that becomes your own research. Or you can write the song and put in different ragas, bind in different ragas. That will be your original. In every field, there is opportunity for the research. Only you have to keep your eyes open and look at the nature and find out the research problem. Every walk of the life in science, scientific bent, in every walk of life, scientific bent of mind is necessary. So you should have scientific mind, and on that basis you can go for the research, where research gets generated because human mind possesses curiosity and inquisitiveness, which is the mother of knowledge. As human being, in other animals, in comparison to all animals, human being has a tremendous curiosity, and that is the reason curiosity and inquisitiveness, utsukta jala in Marathi we call, that results into the research. In the healthcare, how research is done? Advances in healthcare management occurred from centuries. The research done by the scientists, doctors, even common man also can do the research in the medical field. There are many common people in the rural area or in the other areas where they know the herbal medicines and they are in use. They do the research. That is that they are also scientists. Our Indian saints and rishis, Charaka and Sushruta, ancient doctors improved knowledge about the health and disease by simple observation and experience. Means our scientists, the common man or even saints and sages, they just looked at nature, observation and experience. On that basis, they developed the science. They were not knowing the facts, but they had not doing the modern experiments, but still on the basis of observation and experience, they have developed the science of medicine and remedies to the patient. And same practice is followed by the modern medicine for the development of medical science. The reason for medical research, why there are reasons for medical research. Develop scientific mind. And when you want to develop scientific mind, you ask question. When you want to do research, you ask question how. For anything you ask question how, why, when. When you ask these kinds of questions or any thought, then you will find that you will get immediately you can get the problem on which you can do the research. Generate new knowledge and improve scientific understanding, service to humanity. For that reason also research is done. Research is done to improve medical treatment, cure rates, avoid errors, medical diagnosis, perfect diagnosis, and perfect treatment. The research is done. Develop scientific attitude, practice evidence-based medicine. Means first you should have the proof. Modern medicine says, I want proof. Then I will, accordingly, I will proceed. And they don't believe in the Ayurveda. Because in every case, exact, we cannot reason out exactly what has happened. Although there is cure, the scientific proof, the scientific base is very difficult for Ayurveda, but still nowadays we are combining modern science and the traditional Indian knowledge so that we can consolidate the principles of our traditional Indian knowledge for the modern science. To make scientific publication, that is very, very important. Why research is done? Publications are necessary. This publication, because the methodology which is given in the publication is scientifically correct, because using your publication, when any person that 1,000 miles away wants to do that experiment, repeat the experiment can be repeated if your publication methodology is absolutely correct. Means it should be reproducible, and for that important. And even in your curriculum you can put. So in this way, success is not final, and failure is not fatal. What counts is that one continues to work, perform the research. You should continue the research. Maybe you may get negative results, still that is a research, and one should do it. Now, when we want to go for research, opportunities, I told you which are the opportunities. Now, when you are decided that I want to do the research, then in the research you must know two things. One is topic and one is question. You want to select particular topic, and on that topic you want to do the research. Okay. Then well-crafted questions guide the systematic planning of research. Your question which is selected, problem which is selected should be perfect. Then your research will be streamlined. Then your research will be what we call targeted research. While developing the research question from your ideas, you should ask yourself following questions. Means when you want to select a topic and you want to do the research on that topic, then in your mind you should ask the questions. Do I know the field and its literature well? Means whether I have a thorough knowledge of that work, the topic which I have selected. What are the important research questions in my field? What are the problems there? What areas need further development, exploration? Further, what kind of research I can do? Is my proposed research ethical? Very, very important. Susanskarit research, ethically correct research should be done. That research should not affect unethically the society. And you have to ask question that my research is whether it is study is ethical or not. Could my research fill a gap, lead to a greater understanding? Has a great deal of research already been done? मेरे टॉपिक पे पहले काम किया है क्या? कितना काम किया? Whether I have got some opportunity to do the research in that field? ये क्वेश्चन भी आपने पूछना चाहिए. Has this research study been before done? पहले किसने किया है क्या? Whether I have got some room for the improvement? मेरे लिए कुछ काम करने के लिए बाकी है क्या? Is the timing is right for this question to be answered? Is the hot topic or is it becoming the obsolete? मैंने जो टॉपिक सिलेक्ट किया है वो अच्छा है क्या? बर्निंग टॉपिक है क्या? या इट हैज बिकम एब्सोल्यूट, आउटडेटेड? वो भी आपने पूछना चाहिए. वुड फंडिंग sources interested for every research funding is required. So whether you will require funding, then that is important. From where you will get the funding, then these questions you should ask. If you are proposing a service program, then whether society is interested, community is interested in your research or not. Merely your selection of topic is not important. If you want to work on the society, the people should cooperate you. They should be interested in your research. Accordingly, you should select that. Most important will be, my study has significant impact on the field. A strong research idea should pass so what test. So what test is every time you should ask so what. So what question you should ask to you. And if it is passed, then your problem or topic will be top. Now research, just I want to talk topic. Topic means when you select any topic for your research, it is a broad topic, general area. For example, topic is broad topic is tuberculosis disease. Then if you want to work on tuberculosis, then tuberculosis is a big topic, broad topic. In that tuberculosis, which work you want to do, that will be your question, that will be your problem. So you have to select narrow and precise bit of topic from tuberculosis. Say for example, specific topic, prevention of tuberculosis in society. How to prevent tuberculosis in society, that you want to study, not whole tuberculosis. what is the organism, how it is causing disease, which are type of, what are the symptoms, and what is the problem. No, I want to study only how to prevent the tuberculosis in society. That is the difference between topic and question or the problem. Research question captured in acronym. Acronym is group of word. PICO, P-I-C-O. It is a group of word. P-I-C-O. P stands for project patient. I stands for intervention, means what you are doing. C stands for comparison, group for compare standard and this thing you can compare. And then what is your outcome? What are your results and conclusions? That is important. Focus the research on narrow base. You have to select only narrow base. Don't select broad base for your research. Then in the research, how to generate a research question. Okay, you have selected that in the tuberculosis, that small bit I want to take. Then you have to select your question based on earlier work. Say, for example, Watson and Crick have discovered the structure of DNA. On that basis, can you do any research work? Yes. Discuss study the structure of DNA. That is called structure B of the DNA. But on that basis, further work is done by other scientists that there are A, B, C, D, E like structures of DNA. Means on the basis of earlier work, if there are chances for further work, you can select and accordingly you can develop the question. Repeat the work. You can repeat the work. So, for example, DPT vaccine has got some side effects. Fever is there, temperature after vaccination. Then you can study whether some other side effects are there or how to reduce the side effects. The work already done on DPT vaccine. Still, you can work on that with some other problems which are not studied. Serendipity discovery, that is we have discussed penicillin Fleming, or we have discussed Louis Pasteur. He has told that the chance, that is a prepared mind is favored by other chance. Means your mind should be prepared. Then you will know that chance has come. Otherwise, or in other words, it is said, opportunity knocks door once. You should know that opportunity has come. For that purpose, you should be prepared. Otherwise, opportunity has come, it has gone, you are not understood that opportunity has come. So you should be always prepared for the research. And you should have the out-of-the-box thinking. That is the thinking of the scientist. That should be there with you. Serendipity discovery always can be there if you are prepared for the research. Need of the society. You have to say the problem on the need of society or country. Say, for example, COVID vaccine. Or in our area, Dr. Bavaskar is there. In the Raigad region, hills region, he had developed a treatment for scorpion bite. And one chemical he had developed, which is the alpha receptor blocker in the nervous system. And for scorpion, excellent treatment has developed by this person. So that is the need, that was the need of time. Your interest, your own interest should be very important. So Watson had an interest in DNA structure. So if you are not interested just by force you are doing, then that is of no use. It should be of your interest. By discussing with, you can select the topic or problem. You can discuss with you. If you have no idea, you can discuss with your guide. You can discuss with your teachers, your friends, relatives, students. Every teacher, I told, he is a student, lifelong. He can learn many things from the students. So he can get even research problem from the behavior or the idea of the students. Or here prepared mind and observation. That is the Selman vaccine. I told Waxman, he discovered streptomycin antibiotic for control of tuberculosis. How it was done? Because his observation was very important. He observed that tubercle bacilli, they are killed in soil. And he found that in the soil, there is one bacterium called Streptomyces gracious that produces streptomycin. And this streptomycin kills the tubercle bacilli. So this is very important. And another thing, in spite of that, another aspect is their institution. Institution means from your inner mind, when you get some idea. And that example, benzene ring discovery. We know benzene is the ring structure, hexagonal ring structure is there. The scientist discovered, name is Kekulé. He was involved, what is the structure of benzene, and day and night he was thinking on that. And one night when he was slept, in his mind he found that he got a dream, and in the dream one snake took his part of his body in his mouth, especially the tail region, and that ring-like structure he observed in his dream. And then he got the idea, probably the benzene ring is benzene structure is a ring-like. This is intuition. This is called intuition. This is well known that it is reported in the science. Equilage's findings and his dream, how it helped him. That is called the institution. Criteria for good research. This question. Another acronym is there. It should be feasible. Time-wise, when you select a problem, if you find that it requires 10 years or 15 years, then it is of no time, then no use. So it should be time-wise feasible, money-wise feasible, material-wise feasible. Everything, whether it will be available or expertise, instruments, which instrument you require. If you require, say, PCR or the CT scan or the, if very high-end equipments are required and they are not available with you, then that is practically infeasible. So you have to think on that also. But nowadays, this problem can be solved because many institutions, they are giving a hand of help for such facilities. And it is interesting. It should be interesting. It should be novel. It should be ethical. Ethical in the sense that in the medical science, you must be knowing there are many codes. Nuremberg Code is there, Helsinki Declaration is there, Belmont report is there, World War II, German doctors, what happened in the German, that the doctors killed many prisoners. After that, many standard operations and many reports and declarations they came to control such things. And these are the guidelines. So these guidelines, ICMR guidelines, medical research guidelines are there. And for the ethical kind of research, this is today also, if you want to do any research work on the animals, one cannot directly do it unless until he gets the permission from ethical committee. What kind of work you are doing? If it is unethical, then you are not allowed. So for that purpose, we should be proud that Charaka, in the Charaka Sahita, 16 years before BC, before Christ, 1600 years, he has written that Sahita, that when in the medical, if you have to do any experiment, what should be the guideline? That nowadays it is called this kind of Nuremberg Code and all that. But this kind of thing has grown in Indian literature 1600 BC by the Charaka. And R should be your research should be relevant. Means there should be some relevance. Otherwise, if it is of no use for current needs, then it is of preferably should not be taken in hand. Now, how to prepare outline of the research? When you want to prepare you have selected the topic. Okay, research topic is selected. Question is selected from that. Say tuberculosis, and then how to prevent the tuberculosis, like that. Question is selected. Then hypothesis, prediction you have to predict that what will happen. If I want to do the work on that, what will happen? What will be the expected outcome about my research? Whether I will be able to go for research and I will get outcome that we can definitely prevent the tuberculosis in the society. So you have to go for hypothesis accordingly. Then you have to set the objective, exactly what you will do in the research. You have to write the objectives 1, 2, 3, 4, like that. And then on the basis of objectives, you have to go for survey of literature. Previously published work on that topic. You need not to go directly on the whole topic of tuberculosis. No, how to prevent tuberculosis in society. On that, you can get n number of research, hundreds of research papers. Select only those and go for the literature survey review on the recent 5 years topics in the relevant field. And then on the basis of that literature survey, you will get the methodology from the survey. And if you have your own idea, or if you discuss with even good doctors, you can get the methodology. Standardize the methodology. After that, you do the work, and it should be the timely planned work. Proper planning of work is there. And after getting that, huge data will be collected. That data you can analyze statistically, give the statistical support, and after that, you can your data in the your results you can discuss you can compare first with the previous work done and see whether your work matches with the previous workers, and or if your work is not matching with the previous workers, then you have to justify, give the explanation why it matches, why it is not matching, and on that basis you can give the thorough horizontal and vertical discussion on your data. And then you can draw final conclusions. You can give the even recommendations also. In this way, you can prepare a protocol, your outline of work, how I will go for this work that is called the plan of the work or protocol, outline of your study proposal. And then after when you do work, then this is the next part, which is the thesis writing. We write the thesis. This is a common methodology how to write thesis. First is the title page, then certificates, guide certificate, then undertaking by the student that I have not done any plagiarism and all that. That plagiarism certificate also is to be given. Undertaking by the research student also that this is the authentic work, genuine work. Then acknowledgement given by the students to the who helped him. Then a list of the tables, list of the figures, photographs, that should be given thoroughly. Perfect matching should be there. Then table of contents, what the chapters are there. Then you can write the chapter, whole chapter, that is the introduction chapter of your thesis. Say, for example, that tuberculosis related topic you have taken, then you talk about tuberculosis, and on that last 1 or 2 pages, you can talk about the justification of the topic which you have selected, that how to prevent the tuberculosis in the society. Last 1 or 2 pages you can write in the introduction. So you can write 4 or 5 pages introduction commonly, or even less than that. Then you can write the chapter aims and objectives of your research, and then the review of literature I told related to your aims and objectives. You can write thoroughly material and method. That's very, very important chapter in your thesis, because methodology should be scientifically correct. It should be world accepted methodology. If any change in the methodology is made by you, then and then detailed methodology is necessary. Otherwise, you can just mention the references also for the well-known methodologies. And after that, then all the results you have to collect those data. That is scientifically you can plan that data. Statistical tools are used. Software is used like this. SAS is there, SPSS is there, Medicaid is there. So using that, you can analyze whole data, present data extremely well, and then you can draw the conclusions from your data. Discuss your whole result either that vertically, horizontally. Tables are discussed. Thorough discussion with comparison with previous results, previous reports you can do, and then you can write, summarize your whole work in 1 page or 2 pages, and then you draw finally 2 or 3 conclusions from your work. Be careful in the conclusions. Don't repeat the results section. Draw only the figures in the results. They should not be repeated in this unless it is absolutely essential. Otherwise, results part is not repeated here. Then you can recommend in your this thing what recommendations are there in your research. Then by bibliography, that is the references you have taken the review of literature and all that references right from your beginning, introduction to methodology to the everything. Then you have to write these references by scientific manner. There are different scientific methods on that basis. Scientifically accepted correct methodology should be used for the bibliography. And then you can write the appendices. Say, for example, what kind of chemicals you have used, what kind of the nutrient media you use, everything what you have used, all the detailed composition should be given in that your appendices. And then nowadays you must be knowing that before submission of thesis, you have to have some completions which are to be done by the student and they are given by the UGC. That is, you have to publish research publications. That is at least 2 very good papers in the well-read journals. High-read journals, it should be there 2 papers. Scopus, for example, and 1 or 2 conference presentations should be there. Peer-reviewed journals should be used for publication of papers with high impact factors. But nowadays you must be knowing, recently UGC has given a guideline that it is not compulsory. But if any university wants that these kind of publications are needed before submission of thesis, then one has to follow. Otherwise, it depends upon the university because our universities are autonomous and they can follow the UGC guidelines. And then ethical committee certificate also it is required that a certificate is taken from the ethical committee. It is satisfactory. In that way, you can prepare the thesis, and after preparation of thesis, soft copy nowadays people they submit. Hard copies also they are being submitted. Soft copies are given to the referees, and preferably the referee from the own state, outside the state in India, and one from the outside country. 3 referees are there, and the guide is the internal referee. Out of these 4 referees, if more than 2 referees they give positive reply, response, then YY the open defense is there, and then open defense is just formality. If it is completed, the degree is declared. So in this way, one can go for the research, and if you are to go for PhD, this process is followed. Now, in the process of the research paper publication, I told that you have to publish the papers, publish your work. So preparation of papers, that is called manuscript preparation. So you have to prepare title, names of the names and address of authors. Who are the authors? Who have prepared the research student is there, his guide is there. If somebody he has help of somebody, his name is also to be given. But you have to mention there who is your corresponding author in that. Generally, student of PhD thesis is the student is the primary author, corresponding author. So he's responsible with a major responsibility. Then you can write the abstract of the 8 to 10 lines abstract, which is in the past tense abstract is written in this. Then keywords you have to write, which are the keywords in as per title. The title is the mirror of your paper. So on that, you can write the keywords. Then you can write the in brief introduction in the present tense, material method, the past tense. Then your results and discussion in the material methods, as I mentioned, that if you have modified any method, then you write detailed method. Otherwise, you can give just reference of that method. Then results, as I told, this section should be given more emphasis, where results should be properly presented and they should be thoroughly discussed. And you can write the conclusions, acknowledgements that you have, your university or somebody has helped you. Then you can write the recommend, you can acknowledge that. Then conflicts of interest, that is the understanding, that is very, very important, that you have to give undertaking that there is no any conflict of interest between the these writers of the paper. If 3-4 writers are there, authors are there, that we have no any problem with each other for this, and plagiarism understanding that letter also should be given. The paper soft copy prepared as per the instruction of chief editor of journal. You can select these journals first, go to their instruction to the authors, and then the editor has given some selected type of the guidelines. On the basis of that, you can prepare the paper, then send to publication, mail to the chief editor of that journal with charges, and then after that review process, then you get the answer from that, whether accepted or rejected, or accepted with some changes, or flatly it is rejected. So if it is accepted, then you get the Galley proof after that, and then you get the published papers either online or offline. So this is the procedure for the publication of research paper, and every scientist, including every teacher like we must know this procedure. And most important thing is try to publish in the journal which are well-known journals, scopus journals. See, nowadays crop of paper journals is everywhere. Fake journals are there, and don't go for such journals because in cheap rate they publish, but you will find that these journals are of no use to you. Even in the promotions also they are not considered. So you publish just Springer journals or scopus journals are best way. Q1, Q2, Q3, Q4 category journals. The top category journal called Q1, then Q2, Q3, Q4. If your papers are in these 4 category journals and these scopus, then you will find that they are of good quality papers. So try to publish in these good quality journals. Your research will be valued. And in the research after that, you can try for intellectual property. If your research work is of that potential, you can go for patenting. After patenting, you can, if your patent has got, say for example, industrial process is there, industrial product is there, and that product has got commercial application, then you can contact to industry. Many industry can come to you. Say for example, nowadays there is everywhere there is problem of waste treatment. The waste which is produced by alcohol industry, as a distillery industry, no good treatment is there. But tomorrow, if you develop a treatment method to treat that, all these distilleries they will run behind you, and you can give you'll be at the driver's seat, master seat. You can sell it out by your own cost, by the cost which is of in your mind, and you can sell it out. So that is the commercialization. You can go for ideation first, and then you can go for this kind of commercialization. All these startups are there nowadays. If you are innovative ideas, ideation in there, then you can contact the incubation center, startup centers, where they will help you to develop your whole research work, and they will take that. It will be incubated in the incubation center, and after that, with their help, Even they help in the funding agency different, they will help you. They will help you, and then you can go for patenting, process and product patenting, feasibility and testing for the commercialization. You can. This is another aspect everybody should try. And finally, the research finance aspect. Work should be done in logically and minimum required infrastructure and facilities. So many times people they say that I don't have the facility in the laboratory. I don't get. Even arts commerce people they say in the library this book is not there, that thing is not there. We don't get the facilities another way. But see that minimum facility should be there. I give the example here. Louis Pasteur, he has made 14 outstanding contributions in biotechnology and microbiology. Every contribution is heavier than a Nobel Prize. Means he should have obtained 14 Nobel Prizes. Unfortunately, at his time, Nobel Prizes were not there. He died in 1891. Nobel Prize started in 1901. But his infrastructure, if you look at, just wooden table was with him. 4x3 wooden table, 2 petri plates, 1 wire loop, 2 spirit lamps. In that outstanding facility, he has done this work. Means if you are inborn scientist, then you should not bother about the infrastructure required. As you start working, you get the solutions. Whatever is infrastructure is available, in that you can do. C.V. Raman is another example. He worked in minimum possible facilities. He also got the Nobel Prize. Funding agencies are there in our country because you need research for research funds. Many times universities they provide. Say for example, my university is there. If any student gets admission to PhD in my department, my college, 100 students they are doing PhD. For each student who has joined to my department for PhD, he gets 25,000 rupees per month as a stipend for PhD. In this way, many universities are there. Many industries also they provide as a social responsibility. They provide the funds. In addition to that, in our country, many funding agencies they are there. UGC is there, CSI is there, DBT is there, ICMR is there, DST is there, ICSRI is there, DRDO. So many they are there. And if you pass there, say for example, UGC CSI exam, which is we call G.R.F. If you pass at the beginning, you can get more than 30,000 rupees plus HRA. And if you become SRF after say 1 or 2 years, then your salary, that scholarship is increased. And that goes more than 60,000 rupees per month. So in that way, plus you get continuous amount required for research purposes, attending conferences, traveling, printing, all for all that purpose, 5 lakh or more than that amount is available. Huge amount is available for the research. Only thing is that keep eyes open and try. Definitely through proper channel you will get these things. Sponsorship from industry, that is the corporate social responsibility. Through that also one can get. If you say approach to industry and say that I can solve your problem by the research. If you first find out what is their problem, then that industry also can provide the funds. And if you look at the research, the sky is also not limit for that. In the beginning, I told sky is limit. I thought that sky will be the limit. But if you look at all these things, you will find that sky is also not limit for all these avenues. And you as a budding scientist, young people, you will find that if you want to develop your career in this academics and want to go further, definitely do the research. And number of avenues are available. You are lucky generation, computer and all that. And nowadays AI is also available, so that you can develop excellent career in your life and fulfill dream of your parents, your own dream, and dream of our country, that is the Make in India. Thank you very much.
Thank you so much, sir.
Thank you, sir.
Thank you, sir.
If anybody has any question, I will try to answer. I want to ask one question to the organizer. How many science people are there and how many non-science people are there?
Most of them are non-science persons.
Oh, I had no idea about the call. Okay, okay. I thought majority will be science people, and in that science people, the health science, life science people will be there.
But it was good
So
lecture, sir, to know some
I
innovative.
tried level best to make it simple, although it is a scientific field, but I tried my level best.
Now that is the idea of NEP, that we should know everything about
Yeah,
all.
yeah, because that is yes, yes. We should be a jack of all trades, but master of one at least.
Yes, sir.
We should know all fields.
Yes, sir.
Thank you, madam. Thank you very much.
Thank you, sir. Thank you. Madam D'Souza, madam.
Yes, ma'am, I'm
Good
here.
vote of
Thank you so
thanks.
much.
Pathade,
Yes,
sir.
yes.
Vote of thanks.
Good evening,
Yes.
everyone. Dr. Sarah here. Sir, thank you so much. It has been actually, I'm honored to have introduced you, sir, and again witnessed your session personally. And even though I've completed my PhD, sir, whatever you said has been a tremendous help and refreshment to my research journey personally, sir, on that note. So I would really like to take this opportunity to tell you that your session was truly enlightening, and we are very grateful for your time and expertise as well. I also would like to thank the participants and our organizing team for including such a refreshing and a valuable session in our training program today. So thank you once again, sir, and we look forward to incorporating all you spoke about research, IPR, publishing, about the journals, once again in our research journey. Thank you so much, sir.
Thank you. Thank you.
Thank you, madam.
Can I take leave, madam? Can I take leave?
Yes, 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 sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Thank you. Thank you. All the delegates, thank you.
Okay,
Yes,
sir.
sir.
Thank you.
Can we leave, ma'am, now?
Yes, you all can do. No problem.